everyone. Today we're going to work on our notes/homework day 4. Okay, this is going to be a little tricky. I'm going to warn you up front. We're going to go through it slow. You can rewind, and we're practicing Monday. So please stay calm. Don't freak out. Stay with me. Okay. The other classes have been working on volume of 3D solids. Okay, so you've kind of missed that. We're going to see a little bit today mixed with Pythagorean theorem. Okay, so for the warm-up, it says for each question below, identify which solids the figure is made up of. Okay, so the top here, we call that a hemisphere, half of a sphere. And the bottom is a cylinder. Okay, for number 2, okay, the top and the bottom are related. Okay, we have to look at the dimensions. You'll notice that the bottom is 4 by 4, which means that the base is a square, but the side is not 4. So we can't call it a cube. We call it a square prism. Okay. But because the base is a square, that means that the base of this pyramid is also a square. So we call this a square pyramid. And then number 3, okay, the top here is a cone. And once again, the bottom, we're looking at a cylinder. Okay. And those are what we call composite solids. Okay, 2 3D solids, 3D figures put together. That's what composite means. Okay. If we flip the page to get started, okay, we're going to be, like I said, putting Pythagorean theorem together with volume of solids. Okay, so real quick, a refresher. I don't know how familiar you are with these formulas, but let's go through them real quick. Okay, any type of prism, okay, in order to find the volume, we want to do area of the base times the height. So in this particular case, the base is a triangle. We call this a triangular prism. So we would find the area of that triangle times the height of the prism. On the warm-up, we saw a square prism, so we would find the area of the square multiplied by the height of the prism. For this one here, we're looking at a pyramid. Okay, so again, similar to the warm-up. We need to find the area of the base times the height, but this time we're taking 1/3 of that value. So 1/3 times the area of the base times the height. Cone, okay, is 1/3 times the area of the base times the height. So same formula, but this time recognizing that that base is a circle. And in order to find the area of a circle, we need to do pi r squared. So it's 1/3 times pi r squared times the height. Over here we have a cylinder, which is just area of the base times the height. So similar to our prism, but again, the base is a circle. So you're going to see it written more commonly as pi r squared h. And then lastly, we have a sphere. The volume of a sphere is 4/3 pi r cubed. Okay, be careful that this one is cubed, but the rest, the radius is squared. Okay, so now let's use those to just get a little practice in. I'd like you to pause the video, give these a try, and then come back once you're ready. Okay, now that you've tried these on your own, I'm going to go over them very quickly. Jot down any questions you have. Feel free to pause, rewind, and we can talk about it Monday. I prefer that you always write down the formula before you substitute and before you simplify. So for the cone, the volume equals 1/3 pi r squared times height. Volume equals 1/3 times 3.14 times, oh, this one's actually nice. Okay, we don't have to calculate the area of the base. They gave it to you, didn't they? Okay, So this right here, okay, they've already told you is 12. How awesome is that? Times the height, which is 8. 1/3 of 12 is 4. 4 times 8 is 32. And for a 3D figure, it's always your units cubed. Volume is always cubed. Okay, for number 18, we have our cylinder. Okay, volume equals area of the base times the height. Volume equals pi r squared h, but they've already given you that base, which is 8, times the height, which is 6, giving you volume of 48 centimeters cubed. Your sphere, volume equals 4/3 pi r cubed. Volume equals 4/3 times 3.14 times 2 to the 3rd power. Volume equals 33.5 centimeters cubed. Triangular prism. Okay, we'll have to do area of the base times the height. Okay, when you're trying to represent area of the base, it's always a capital B as opposed to a lowercase. Okay, area of this base is 5, and the height of the prism is 7, leaving us with a volume of 35 centimeters cubed. And then for this pyramid, okay, if I look at the base, I'm noticing that that base is a rectangle. So we have a rectangular pyramid. Okay, and we'll need to find the area of that base before substituting it into the formula. Okay, so that base will do length times width, which is 3 times 5, which is 15. So now when I go ahead and do 1/3 times the area of the base times the height of the pyramid, I'm all set to do 1/3 times 15 times 3, giving me a volume of 15 centimeters cubed. Correct your papers, jot down any questions, and then we will move on. Okay, this is where things get a little intense. Using the Pythagorean theorem to find volumes of composite solids. I'm going to be honest with you, this first example is harder than the second, so why don't we start with the second and we'll work our way backwards. Okay, I'm going to try my best to go slow and steady. It might benefit you to watch all the way through first, then rewind and take the notes with me. And then again, jot down any questions and we'll go over it Monday. Okay, this says a solid metal trophy is made up of a cylinder and a cone, which hopefully you can recognize. The radius of the cylinder is equal to the radius of the cone. Okay, so this right here is the radius of both those figures. Find the volume of metal used to make the trophy. Round your answer to the nearest tenth. Use 3.14 as an approximation for pi. Okay. I like to start with my formula so that I know what's missing, what I need to find, what I'm plugging in. Okay, so when I'm trying to find volume of a cone, I'm going to use my formula. Okay, volume equals 1/3 times pi r squared times height. Okay, and that pi r squared is the area of that base. Okay, so looking at that and looking at my cone, okay, I'm thinking to myself, okay, I know the radius is 6, but I don't have this height of the cone. Okay, that's what's missing. Okay, and we're going to need to use Pythagorean theorem to find it. Okay, so that's where the two things tie in. Okay, we're also going to need to find the volume of the cylinder. Okay, and that formula is volume equals pi r squared h. For this one, we do have the radius, which is 6, and we do have the height of the cylinder, which is 5. So that one's all set. Why don't we do Pythagorean theorem so that we can get started on the cone? Okay, so maybe off to the side here, we'll do a squared plus b squared equals c squared. And I'm going to let this 6 be my a squared, for my a. Okay, so we'll have 6 squared plus, I'm missing the b, so I'll just leave it as a b squared, equals, the hypotenuse is the 12, which we will square. We will have 36 plus b squared equals 144. Subtract 36. B squared equals 108. And to be honest with you, I would probably leave this in exact form so that we're as precise as possible, at least for now. Okay, so we're going to say that this height is square root of 108. Okay, so now I am prepared for this formula. Okay, so I have volume equals 1/3 times 3.14 times the radius squared, which will be a 6 squared, times that height, which we just said was square root of 108. Okay. If you want to put that entire thing in the calculator, you can. Sometimes I like to break it down. Okay, and acknowledge that 6 squared is 36 times the square root of 108. Go ahead and multiply, and we round to the nearest tenth. We should be getting 391.6 centimeters cubed. Okay, so there's the volume of the cone part of this trophy. Now we have to find the cylinder. Okay, so we have volume equals 3.14 times the radius, which is 6 squared, times the height of the cylinder, which is 5. Okay, so again, 3.14 times 36 times 5. Volume equals 565.2 centimeters cubed. We are not done, but we have done the hardest part. Okay, in order to find the total volume, we need to add the two of those together. Okay, so total volume equals 391.6 plus 565.2, which equals 956.8 centimeters cubed. And now we have our final answer. As you can see, it's a long and careful process. I know it's a pain in the butt, but we got to do it. Okay, so stick with me. Again, slow and steady, rewind, rewatch. I'm going to flip backwards to the first example, and we're going to do this one together as well. Okay. So this is similar to the warm-up in a lot of ways. Okay. If we look here, there's this tiny detail, okay, that lets us know that all of the sides of that base are 5, okay, which means that that base is a square, which means that this base of the pyramid is also a square. Okay, so we also know that this is 5 by 5, just like we know that the base of that square prism is 5 by 5. Okay. So our formulas, we have a pyramid. Okay. And the volume formula is 1/3 times the area of the base times the height of the pyramid. And we also have our square prism. And the formula is area of the base times the height of the prism. Okay. Looking at this pyramid, I can find the area of the base no problem. Okay, it's a square. In order to find the area of a square, we're just doing length times width. Okay, 5 times 5 is 25, easy peasy. What we don't have is the height of that pyramid. Okay, this is going to be real funky, but we will get through it. Okay, there's 2 steps we're going to need here. The first thing I'm going to do is cut through that base diagonally. Okay, and we're going to look right here. Okay, and you'll see why in a few minutes. Just stay with me. Okay, this is a right triangle. Okay, so we're going to use Pythagorean theorem to find the length of this diagonal. Okay, a squared plus b squared equals c squared. 5 squared plus 5 squared equals c squared. Okay, so we have 25 plus 25 equals c squared. C squared equals 50. C equals the square root of 50. Okay, so this length here, this diagonal, is square root of 50. Okay. Now back to this. Okay, the height of the pyramid. Okay, and watch what I'm doing. This height plus half the diagonal plus the slanted side. Okay, we know the slanted side is 6. Okay, that's your hypotenuse. Here's your new right angle. This here is half of the diagonal, so it's that square root of 50 divided by 2. Okay, again, it's this cut in half. And what we're looking for is this side here. We'll call it A. Okay, that will give us our height. So once more, a squared plus b squared equals c squared. We're looking for that a squared. We're looking for that height. Plus, we have the square root of 50 divided by 2 squared equals 6 squared. Okay, right? This is your b, this is your c. Okay, remember we discovered that when you square a square root, it just goes away. So that becomes a 50, and then 2 squared is 4 equals 36. Okay, 50 divided by 4 is 12.5. Subtract a squared equals 23.5. Take the square root. You can say the b is about 4.8, or we can just leave it as square root of 23.5. Both of these are representing the height of that pyramid. Whew, seems like after all that work we should be done, but we haven't even used our formulas yet. Okay, volume equals 1/3 times the area of the base of that pyramid. Remember, is just that 5 by 5, so that's a 25. And the height is that square root of 23.5. Or if you prefer to use the 4.8, I'm not going to be picky. And then when I multiply all 3, we should be getting the volume is about 40.4 inches cubed. Now the square prism is way, way easier. Okay, again, the base of the prism is the 5 by 5, okay, which is 25. And the height they give us right here is 7. Okay, so 25 times 7 is 175 inches cubed. And to get our total, all we have to do is add those. And you should be getting 215.4 inches cubed. Whew. You should take a break after that one. But don't forget, that back here you have 3 practice problems. Okay, this is a cylinder and a triangular prism. Okay, so triangular prism minus the cylinder. Be careful, that one's not addition. Then you have a cone plus a square prism. Okay. And lastly, you have a cone plus a hemisphere. And be careful, a hemisphere is half of a sphere. Okay, so if you find the volume of a sphere, you got to cut it in half. Good luck. Do your very, very best. Give them all a shot. And I promise I will give this plenty of attention on Monday. Enjoy your weekend.